Welcome back. I want to point out something interesting. We left off on 20 and we did solve for the answer, but I wanted to show you something really cool. One interesting thing that we noticed, and I'm just going to take a little notes off to the side, is that this same triangle had an interesting pattern that somebody a really long time ago noticed. We used triangle sum theorem to figure out this angle is 41, and then the idea of a protractor to figure out that angle X is 139, this bigger angle, the obtuse one. Well, one neat thing that somebody noticed a long time ago is that I could have gone straight to my answer with a shortcut. And you know how the math teachers were lazy. So we see a shortcut that these two remote angles, they're called remote because they're far away from this angle outside here, 41 plus 98 adds up to 139. So that's a little shortcut. Now you didn't need to use the shortcut because I didn't, but notice that pattern doesn't happen just every once in a while, it happens every time. So some mathematicians way back when just jumped straight to knowing if the two remote angles, if we know these two remote, we know this angle on the outside. So I guess what I'm saying is that without using this two-step process, my hypothesis is that I can just add these two numbers together and it should equal X. That's the pattern somebody a really long time ago figured out. And math is all about looking for patterns and noticing shortcuts. And here's a shortcut someone noticed. But let's say on a test you draw a blank, you don't remember the shortcut. I will show you how to use your basic observational skills. So, if you observe a triangle, you know that this missing angle, I'll just call it question mark. Sometimes that's even easier for people to think about. The unknown angle here, those three things, 42, 79, and this unknown have to add up to 180 because it's a triangle. So 121 plus an unknown angle have to add up to 180. So as I subtract 120 on both sides, I notice that this unknown angle is 59. So this unknown angle is 59, but that's not what they asked for. They asked for this angle on the outside. So if I think about this as a protractor, if I measure the angle from this side, it's 59. If I measure it from this other side, it has to be 180 minus 59. 180 minus 59 is 121. Bam. That's the same answer I got, whether I did it the long way or the short way. Great. Well, let's keep going. If you're ready, you can just use the shortcut, but they did change things around a little bit. So these two remote angles have to add together to make this exterior angle. So 46 plus X equals 119. So X has to be 73. Okay. Now again, I hope you see this concept that 46 plus 73 has to equal 119. Because what you're really doing is you're adding these up and subtracting 180, and then over here you're subtracting from 180 again, so you're basically like redoing it, and that's where the shortcut comes in. Okay, these guys, these two remote angles, 23 and X, have to add up to the remote, so 23 and X have to add to the remote, so X has to be 51. Beautiful. Now, just when you're thinking, wow, that was a pretty easy or straightforward, not any crazy math, then they make it more complicated by adding stuff to the picture. So the way we make it less complicated is we take it one step at a time and we use highlighters so we know which relationships we're talking about. So starting with the letter, with the first triangle and the number 1, I notice we know 2 of the 3 angles here. So we should be able to figure out this last angle. 37 is one angle, 116 is the third one, and angle 1 is the third. All those angle 1, angle 2, and angle 3. All those three angles have to add up to 180. So this add up to 153 plus angle 1 is 180. So kind of working backwards, 180 minus 153. The measure of angle 1 has to be 27. Okay, pretty cool. Now, could we get to angle 2? Well, I'm hoping you notice something here, that our protractor would fit right here. Here's a straight line, and I'm just kind of drawing a cartoon of a protractor here. We know this angle is 27, that's 42, and the leftover piece, we know all of these angles have to add up to 180. So it's not two angles like we practiced, it's a third angle, but all three of these angles have to add to 180. So to figure out angle 2, I know that angle 27, the angle that measures 27, and the 174 plus the angle 2 all have to add to 180 because they make a straight line. So that is 101 plus the measure of angle 2 has to equal 180. So it looks like the measure of angle 2 has to be 79. Once again, feel free to plug these back in to verify your accuracy. 79 plus 74 plus 27 all has to add to 180. Yeah. Okay. Now, I see another triangle here to get to angle 3. So triangle, the triangle in the middle here has an angle 74, 48, and angle 3. So 74 plus 48 plus angle 3 all has to add up to 180 because they make a triangle. And they make the blue triangle. So the measure of angle 3 has to be 58. Scoot that up there. Hopefully you can kind of see my work. Okay. Last one. Kind of running out of colors, but I guess I have a darker blue color here. This triangle. 16, 122, and we do not know, so question mark. 16, 122, and question mark. So 16, 122, and question mark all have to add up to 180. Okay, so I get this unknown angle is 42, and hopefully you notice the protractor. So if I laid a protractor right here, zoomed in really big, the smaller angle is 42. That means the bigger angle has to be 180 minus 42. So 180 minus 42 has to equal the measure of angle 4. 138. Okay, so the measure of angle 4 is 138. It's a measurement. It's a big obtuse angle. It's got to be bigger than 90. Okay. Now, you may have seen this shortcut, and you're like, oh, she did it the long way. Well, yeah, because we're still learning. But notice 138 would have been the same as adding this 16 and 122. That would have been a shortcut. You could have taken the shortcut. Cool. All right, last question. We're almost done. It says a flag on a golf course is in the shape of an isosceles triangle. Okay, so if I played golf, which I do every once in a while, so here's my golf flag, and it says it's an isosceles triangle. So that just means that this length and this length are the same. That could be maybe what you're picturing in your head. I could draw another one. Maybe you're like, that's cool, but I want it a lot bigger. So let's make one really big. An isosceles triangle means two of the sides are the same length. Not all three, but two of the sides are the same length. So maybe this length is 3 inches and that length is 3 inches. Or maybe it's 10 inches. I don't know. Maybe it's a really big flag. But if this is 10 inches, that's 10 inches. That's what isosceles means. Now it says one leg of the triangle is fastened to the pole. Okay, so that's this part right here. It's attached to the pole. And that leg forms an angle, an 84-degree angle with the pole. Okay, so this is 84. Now this is an isosceles triangle, so that means it doesn't make sense that the flag would fold it. If I folded this flag in half, it should measure, it would land right on top of itself. So this also, it should make sense, would logically also be 84. Now it's saying, what is the measure of each of the remote interior angles? One leg is fastened to the pole and forms an 84-degree angle with the pole. Even I am a little confused, but I think I could solve this angle, couldn't I? That all 3 of these angles should add up to 180. So let's do that, and I think we'll be done. So if I add all these up, this is my unknown angle. I know that it's a triangle. So they should add up to 180. So to find out that unknown angle, I get 12. Okay. Now, I think that that's enough. So we'll call it a day. The angle we don't know is 12 degrees. Thanks for joining us. Let me know if you got more questions on this question.